to Analyst Crossfire, a supercomputing 2010 wrap-up show featuring expert voices from the HPC community, giving their reactions to some of the top trends from this year's SC conference. I'm Addison Snell with Intersect360 Research, and I'm your moderator for Analyst Crossfire. Joining me on the panel today are two vendors and two users who assure me they are able to address any supercomputing topic I care to throw their way, giving us their personal views and not necessarily those of their organizations. On the vendor side, first we have Peter ffoulkes. Peter, a one-time industry analyst himself, is the VP of Marketing at Adaptive Computing. Good morning, Peter.
Good morning, Addison.
Next we have Michael Wolfe, who sees how new technologies affect programming as a compiler engineer of the Portland Group. Thanks for joining us, Michael.
Glad to be here.
On the user side, we have two esteemed and widely recognized supercomputing lab directors, each well known for their generosity in sharing their opinions. First, Jay Boisseau, director at the Texas Advanced Computing Center, or TAC. Good morning, Jay.
Good morning, Addison.
And finally, a longtime advocate for supercomputing technologies, Thomas Sterling, Arnott and Edward Professor of Computer Science at LSU. Hello, Thomas.
Addison, thanks for the opportunity.
Gentlemen, thank you all for joining me for Analyst Crossfire. Let's get started. Our first topic today focuses on the significant amount of attention being garnered by accelerator technologies at the show, specifically GPUs. 3 of the top 4 slots on the new top 500 list were claimed by GPU-driven systems, Tianhe 1A in Nebula in China and Tsubame 2 in Japan, with the US-based Jaguar system from Oak Ridge still at number 2. Jay Boisseau, what is China's role in the global HPC market, and will the US respond in some fashion?
Well, I think the U.S., of course, recognizes, as does China, that innovation is important and that knowledge discovery is important. I think that the #1 system is a system that many countries could have built. China put the effort into it. It's certainly a system that many countries could replicate and will replicate over the years ahead. But China has tremendous talent and resources, so I think they're going to be a fixture in the top 500, and especially even in the top 10 for the next several years and onward.
Peter ffoulkes?
I would agree. I think that what this shows is not so much about the technology, which now, of course, is available to pretty much everybody, but the fact that China is building their own interconnects, the fact that they are really serious, I think reflects more the global political situation. They are rapidly becoming a very major political power in the world, and HPC is part of that. On the other hand, I think that there's a tremendous education problem to broaden HPC beyond the specialist things and make that more available to the entire community around the world. And if you look at the rate at which China is emerging, it's clearly got the top-end capability, but there are a huge number of people in China that can benefit from HPC, but have a lot of education before they can get there. Will the US respond? Of course, politically. I think from what I'm hearing of the systems that people are already planning, I think are already looking that there'll be a big battle. The US has got that, and I don't think at some level it's as petty as a response. I think it's just furthering science, and the US has traditionally been the leader.
Thomas, what do you think about that, China's role, and whether the US will respond?
Well, it's clear. China wants to be first world, but they want to do that on their terms, not the world's terms. This is a case where they expect the world to assimilate to them, not they be assimilated by the world. And it's not just the flops, although it's a very impressive accomplishment. I was there just a few years ago, spoke with their technical leaders, saw their machine. Very impressive engineering and technology. What is scary is 2 things. First, as Peter just mentioned, they're developing some of their own technology. They didn't have to. They could have bought it. It would have been cheaper, faster, and more reliable initially for them to do so. But they identified the key steps. They identified the system area network. They developed their own I/O processor from scratch, from the silicon up, and they did their own systems integration design. The other thing is, unlike us, they have a long tradition of 5-year plans, N-year plans, and they stay the course, and they will do so here as well. They appreciate where they're behind. They have no doubt that through the procedures, the methods they've applied, that they will be the leader in this field before the end of this decade. With respect to the U.S. response, the U.S. is in deep crisis right now in terms of its federal strategy in HPC technology research. The Democrats don't understand technology, and the Republicans don't fund it unless it's funding defense research. Blue Waters will come online shortly, and it will act as a placebo. We'll again be at the top of the list, and we'll think we're doing fine, when in fact we are way behind in doing research for the future machines by the end of the decade.
Well, you actually bring up an interesting point. I haven't heard anyone all week claim that this top system on the top of the top 500 list is a more productive supercomputer at this point than Jaguar. There are a lot of new programming areas that need to be gotten into. Michael, is GPU computing the architecture for the future in HPC? If so, is it necessarily on NVIDIA? Does AMD ATI matter here? What do we make of Intel Many Integrated Core project for 2012 in this context?
That's a lot of questions all at once. So,
Well, hit them.
is GPU computing the wave of the future? It's interesting that the two announced 10 petaflop systems, neither one of them is using any sort of accelerator whatsoever. You've got the Blue Waters based on IBM's Power 7, and the Fujitsu K system based on their Spark V8, I believe it is. And they're both massively parallel and no accelerators whatsoever. I think a couple of years ago, if you'd asked, are we going to reach beyond 1 petaflop without some sort of accelerator, the answer would have been probably not. But we don't have any 10 petaflop systems designed with accelerators yet. So I think the question is still open. I've heard people say that, yes, we're going to have to use accelerators, and GPUs are the accelerator of the present, largely because they're free. They're paid for by World of Warcraft. So that's, you get what you get. Bill Daly had a very coherent and cogent argument about how he's going to be building machines at the petaflop, 100 petaflop, exaflop, exascale, using the technology they're developing for GPUs, and I think that's fantastic. But is it only going to be NVIDIA? Well, no. It's hard to make money betting against Intel. The mic is a fascinating architecture. It was supposed to be released as Larrabee middle of this year, last year.
At some
It was
point,
coming. They were coy about it.
They were coy, but they pulled that project, but kept the technology. So Intel has several times has changed strategies dramatically in midstream, and they might do so again, but the mic is a very fascinating architecture and certainly has the potential to threaten NVIDIA's
Michael, I happen to agree with you. I think that's an interesting war being waged. It takes Intel a long time to turn the howitzer, but by the time they turn it and get it aimed, it can be a fairly effective weapon. But you skipped right over AMD and ATI.
AMD and ATI, right? They've got the raw performance.
and
I
they don't
hear
have the
everyone
software
saying
strategy.
good things about the performance of these chips, but they seem to get lost in the conversation. Let's go back to the other side of the table. Your thoughts on this?
I largely agree with a lot of what Michael said, but I would say that GPU is not the architecture of the future. I would say it is an architecture of the future. I think we're going to have massive complexity, and certainly whether it's a GPU or whether it's mic or some other highly scalable acceleration technology, it will be in there. I expect them eventually to become part of the standard processor architecture in many cases, which will make them ubiquitous and free. And then the key becomes the programmability. I think CUDA's made huge strides. The work that Intel is doing in their research labs and has done, I think also addresses a lot of the problems of programming different methodologies, unifying sort of heterogeneous development environments for different architectures. I see the programmability as being the key.
Jay, your thoughts on the programming challenge here, the productivity challenge?
Yeah, so we support a few thousand users across our different systems, and a small percentage of them are doing GPU programming. Now, those that are doing it very effectively, but it is a harder programming model, and in a diverse user community, you'll always have some hardcore scientists who are willing to put whatever effort is necessary into getting maximum performance, and so we have them using CUDA, we have them using OpenCL. A much larger set think that, for them at least, MPI was hard enough, and they're looking forward to us providing more traditional systems that scale well. So I agree that I think accelerators are an architecture of the future, and I absolutely agree that programming has to be simpler to see greater adoption. I don't want to rule out AMD. I agree with everything my colleagues have said about Intel and NVIDIA, but if you think about it, Intel has the mic strategy now, and they're going from x86 towards accelerators. NVIDIA is coming at it from the other direction. AMD is not out of it. They've got tremendous position because they actually have both technologies, and I think we'll start to see the results of fusion and actually some more interesting things than that over the next 2 or 3 years.
Thomas, back to you on that same question.
With regards to AMD, don't count them out. There is always a role for a low-cost processor socket where products are low margin. And with Intel raising their price because they believe they're improving the performance to cost, AMD will still have a notch. Whether or not they get absorbed by China Inc. is another question. With respect to the GPU, it's the flavor of the month. We've been here before with attached array processors. Yes, heterogeneous will in fact be the architect of the future, but not putting the accelerators so far away in latency and bandwidth that it requires Herculean efforts to program. What we will develop is a uniform execution model for a non-uniform system architecture that scales. That's when we will have arrived.
As we go through all the arguments against accelerators and GPUs, they're hard to program, they're not very productive, they won't work for all applications, ISVs have a hard time. I've heard this song before. We went through this when we went from SMPs to clusters, when we went from vectors to scalars. Thank you, panelists, for your views. Let's move to the next topic. Some people say it's not only at the high end where we find a technology gap in the U.S., but in fact our research has demonstrably proven there's a significant lack of adoption of HPC technologies among small to medium-sized manufacturers and other small business. The U.S. Council on Competitiveness refers to this problem as the missing middle, and some loose multi-vendor organizations, such as the Alliance for High-Performance Digital Manufacturing, seek to enable new adoption of HPC technologies, especially throughout the supply chain of large manufacturers. Thomas, what's the magnitude of this problem in the U.S., and what, if anything, needs to be done to address it?
Oh, it's enormous. Currently, high-performance computing is a boutique industry. With essentially all of the value in the industry in the heads of the practitioners. It is a long, arduous apprenticeship to be able to get the best out of the machines that we're presenting. And yet HPC is really the third pillar both of science and technology, and both of which drive industry. And so we have to resolve this problem. Most computing techniques in education are not about performance. They are about productivity, maintenance, productivity, but they're not about, we are about performance. Performance-oriented parallel computing training is essential, and the HPC modality for essentially all industry is critical. Right now, industry is not taking anywhere near adequate advantage of how HPC can revolutionize their productivity, their throughput, and the quality of their results. So this is the problem to be solved now, and there has to be a close tie between industry, academia, and government, and we are failing in that challenge. Michael, your thoughts?
Well, it really is all about competitiveness. So in the academic world and the science world, they're pretty much self-motivated. They want to generate their new results as fast as they possibly can, and so they're going to do that in the best way they can. In industry, they need to have a competitive advantage. They need to prove that using the high-performance computing is going to give them a competitive advantage. And as soon as someone in their industry demonstrates that, the rest of them are going to follow suit pretty quickly. So Thomas was talking about training. I think we need to, if we really want to get into the HPC, the missing middle, you need to focus on a particular target in each area, and then get one person to convert, and then everyone else will fall like dominoes.
Peter?
I think it's education, education, and education. It's making it accessible to people. And so much of it has already been said. How do you do it? I think the people who are doing it are people like Dr. Happy Sitole with CHPC in South Africa, and outreach to local community for economic development. Rocky Mountain supercomputing centers in Montana doing the same sort of thing. And I think it's HPC cloud. True HPC class systems, HPC as a service, software as a service, make it accessible, make it easy, so that the businesses can understand they can gain competitive advantage and realize they can use it.
Jay?
I agree with everything that's been said, and one thing that I want to add is that the advent of multi-core meant that you could no longer avoid buying a parallel computing system at some scale. And that's a tremendous pressure on ISVs, who had generally waited for the workstation processor performance to increase, and that would carry their application forward. Now, with every system right down to netbooks being multi-core, every ISV is going to know that they're competing against other ISVs on multi-core systems, so they have to invest in parallel computing training and for their workforce. We're seeing a great interest in this from companies that are approaching us about being industrial affiliates of the center, and in particular they're interested in our training classes and in hiring trained graduates that have taken our classes.
I think it's one thing to say that ISVs have to respond and have to invest. Has anyone talked to them about what the business model is for them to go do this? Already we're hearing software cost is the #1 barrier for people adopting HPC. I haven't heard anyone say they feel like they ought to be paying more for software. Anyone have an idea?
Well, I don't think anyone wants to pay more for anything, right? Their businesses, they're for profit, they're trying to maximize their profits. But the reality is, if their competitors are optimizing for multi-core and optimizing for parallel computing systems, they're going to have to do the same as well to be competitive. And it is easier for companies to deploy these systems now. So I think it absolutely has to happen for competitive pressure. It should happen quicker, and training is needed there.
I think for these companies to stay in business as software companies, they've got to address the multi-core issue. Otherwise, they'll lose out. But then, if they can address the missing middle, if they can reach out to the smaller companies, there's a lot of them out there, and if they get competitive advantage, they will pay for standard software, as long as they understand the business benefit.
Michael?
I'm just going to agree with these guys on that point.
Thomas?
In the very short term, a bridging action or a combination of domain-specific languages and frameworks, but these are merely means by which people can provide short-term results in order to make progress. These are not long-term. What we require are paradigms that allow us to take advantage of all of these systems where industry confidence can grow rather than shrink, where the end result of the computation can be applied to the end discipline, not make the computers the end result themselves.
For our third topic today, gentlemen, we talk a lot about computation. It is supercomputing, of course. There's a lot of discussions around processors, accelerators, memory management. But I want to talk about HPC data management, and specifically the evolution of the parallel file system technologies, would have a lot to do with actual productivity of many of these systems. Now, IBM GPFS is sort of a given on that roadmap, but Lustre's roadmap is fairly convoluted thanks to the Oracle Sun acquisition and the statement that Oracle will continue to support Lustre on Oracle hardware, which in itself is a phrase that didn't exist this time last year. And PNFS has been a little bit late, although we are seeing some development with it now. Blue Arc was demonstrating it in their booth. Peter, how important are parallel file systems going to be, and what do you think this landscape is going to look like in a few years?
How important is information? I don't think anybody's got a good solution yet. I think that everybody's wrestling with data locality, data movement. I don't think any of the systems out there that I hear people saying are adequate yet. There are good ones. I think GPFS is doing well. Lustre, I think the problem there is that the Lustre people are running around with a big scarlet O on their chest.
Now, when you say the Lustre people, do you mean people who are at Oracle or people in OpenSFS or WAM Cloud? Whom do you mean? Who are the Lustre people?
I think that the users desperately want to see Lustre get back into the mainstream to be trusted for the future, but at the moment it's tainted, and people are very scared about where that development is going to go. Therefore, it's a risky investment, but I think the community wants it to move forwards. But I would say that its Oracle is putting so much uncertainty there that that's a big challenge.
Jay, TAC has some skin in the game here. What are your thoughts?
Well, we've been primarily a Lustre shop, and so of course the Sun acquisition concerned us because we wanted to see a strong roadmap going forward. While there's uncertainty in the short term, I'm actually impressed by this supercomputing meeting with the information we're getting from the people who are stepping in to fill that void. So WAM Cloud looks promising, Xyratech looks very promising, OpenSFS is an interesting initiative as well. So
I believe Peter Brahm is at Xyratech now.
Yeah.
Interesting development.
Yeah, and a couple of my staff went to their thing last night and were quite impressed with the plans they laid for the future. So while there was some very short-term uncertainty, it's actually interesting at how many credible efforts are popping up that I think are going to really support Lustre going forward. Now, that being said, do I think Lustre is the long-term file system? Well, anyone who runs any parallel file system currently knows they require lots of care and feeding. And they become, for TAC, we've noticed that that's probably been our greatest source of interrupts and our greatest source of system administrator effort. So we definitely need to see improved reliability and scalability in parallel file systems. And I'm not really sure where the long-term research funding for that area is coming from.
Thomas?
Data-intensive computing is critical to much of science and technology. Some in the field believe it is the critical problem at the moment, with enormous applications such as simulation of the large fusion reactor and, of course, the output from the Large Hadron Collider as just two examples, not to mention the entire Earth observing system for meteorology and other characteristics. We have not even mentioned the technology disruption that's occurring with non-volatile RAMs that will create yet another layer in the system. GPFS is a solid system, but it's expensive and not always accessible to the random. Panelists is handling the middle. conventionally, the mass market. PNFS I still consider to be an unknown, and Lustre has been a disappointment compared to what its goals were initially. I would say this is an enormous challenge to the community, and given that we're basing it still on a technology that's 60 years old in its inchoate, I don't know where this is going to go.
Michael?
Well, I'm a compiler guy. For us, a disk is just another level in the memory hierarchy. I really have nothing more to add.
There are, of course, many topics of interest around HPC, and we could spend a long time on a lot of them, but let's get your brief thoughts on one or two more here in our speed round. Peter, tell me about Windows. How relevant is it for HPC?
I think it's very relevant in terms of the missing middle. There's a huge number of people out there in small companies that are using Windows workstations. Go back to South Africa. They're supporting both Windows and Linux, of course, on their systems. They had a small production company, needed to render things. They were using Windows-based software, produced Africa's first digital full-length movie. What happens in the future? I think it depends what happens with cloud. I think it very much depends upon what Microsoft does with Azure. But at the moment, where you've got fat clients running Windows, reaching out to a Windows-based cluster using the exact same skills to get HPC-type capabilities will address that middle range.
Michael, I'm not letting you punt on this one. You're a compiler guy. You better have an opinion on Windows and HPC. Go.
It's not Windows, it's Microsoft. Microsoft will have an impact on HPC because they have the clout to bring people together and make them work together. And no one else in this industry, except for maybe Intel and IBM, is going to have that kind of clout. So Microsoft will make things happen because they have the technology, and they have the money, and they have the will.
Vendors are both for it. Let's hit the user side, Windows and HPC.
Well, I think Microsoft's got a lot of opportunity in this area. It's not clear to me they have opportunity to unseat Linux in environments that have Linux clusters already. But so many environments that haven't moved into HPC yet, the so-called missing middle, are Windows-based environments, as Peter was saying. So tremendous opportunity there. And say what you will about Microsoft. When you need to install a Microsoft package, you hit that install button and it goes. They have the professional software engineering expertise to make it easier to set up clusters and easier to manage them. And then you've got the opportunity for users to move straight from their Windows laptop or desktop onto the cluster. So I think there's a tremendous opportunity there. I'm not sure it's so much in the supercomputing centers that are already moved to Linux, but there's a vast amount of territory there for Microsoft to grow HPC usage.
Thomas.
They can play a dominant role if they get their strategy right. In the non-science workloads for financial markets and scalable commercial, I think that they will dominate, and I think they have a good path going forward. However, they need to figure out HPC from the science and technology point of view, and I don't think they understand that community and the needs of that community as yet.
Nevertheless, we've been seeing it growing as a market share in our surveys pretty regularly. How about another topic of interest, cloud computing? How does it pertain to supercomputing?
Well, we're looking at it, of course, as a way for our users to get ramped up more easily. I mean, cloud computing means different things to different people, in particular if you're on the provider side versus the user side. It certainly has some interesting characteristics as it's usually implemented from the users, which is rapid access to it and not worrying so much about allocations, just paying as you go or using as you go in the case of a non-profit center like ours. So we're certainly interested in the technology, and we think it actually has a lot of potential, in particular for the science and engineering communities that have not really moved into the cluster space yet. In particular, some of our computational life sciences users have requested this. They don't want to become large-scale parallel computing experts. They really want a simple interface, hosted services, software as a service to run their life sciences applications, and it has a really good opportunity in that growing space.
Peter, cloud is central to adaptive computing. Your thoughts?
I think it's definitely going to be something that takes over, but it's not about VMs, certainly not today in HPC.
Takes over is kind of a strong verb there.
Yes, it is. Well, part of the way you can look at it is many HPC facilities are already clouds in almost everything but name.
Right.
They've got all the agility, they've got the automation, they've got all the flexibility. The only thing that's really missing is that abstraction that makes it simpler and you don't see through to the real systems. Now, once again, you talk about the missing middle, I think it's a great enabler. The other thing is the agility. If you're looking to support a whole new batch of users, you can stand up a facility as long as they're HPC class systems rapidly in the cloud rather than getting a new facility, buying systems. That takes too long. Even if you do it as a temporary fill-up, you can empower your users, you can do it fast, and I think that's another huge advantage.
Michael, you watch people develop applications. Your thoughts on cloud computing and HPC?
For capacity-type computing, I think the cloud is appropriate. For capability computing, I don't think it addresses that, and so I don't think the HPC centers are going away. Speaking as a vendor, providing services in the cloud is a challenge that we haven't solved yet.
Thomas.
If they get the economics right, they will be able to offload much of the HPC workload and enhance the overall workflow for high-performance computing. However, the hype is out of control. Cloud in Iraq, give me a break. They are confronted by significant problems of security, of long-distance bandwidths, of incompatibilities, protocols which are shared ubiquitously, and pricing. Pricing is not right yet. So we're dealing with another fad which I think has substance, but we need to get real about it.
I'd like to make a comment there if I could, because it depends how you define cloud. And if you have private cloud, if you own the facility but you're using the methodology, a lot of those problems of security, even the bandwidth, all of those things can go away. And if you're operating at a large scale, it's often cheaper to do it yourself than it is to go for a public service. So it really is all about the definition of cloud, I think. There's capability there, and it's not always going to somebody else's facility or a pay-for-play service.
So many of the same arguments we heard around grid, pro and con. It really is a rerun on a lot of these same topics. Final speed question, panelists, similar to a question I asked a lot of people last year. This is a very simple question, and I would like you to give me specific odds on this proposition. Will Oracle have a booth presence at SC10 next year? Jay, this is close to your heart. I want odds. Oracle at SC10 next year.
I have no idea, 50-50.
Peter.
Oh, I'd say 10 to 1 against. It might be a flat, empty piece of concrete, nobody there to staff it.
10 to 1 against from Peter. Michael?
99% they definitely will be there. They don't want to give up their priority in the booth selection list. You can't miss a single year. And they may not be in the industry they were in before, but these are the people they want to talk to.
99 to 1 in favor. Thomas?
They have a veneer problem right now. They'll be back. I give it 98%, and the last 2% depends on whether we get hit by an asteroid. But they are straining their welcome, and they are losing friends in the HPC community.
So you say there's a 2% chance we're going to get hit by an asteroid before next year?
I'm being pessimistic.
Last year I put it at 7 to 5 in favor and narrowly won my bet. This year I don't see a focused HPC strategy from Oracle. I'm going 3 to 1 against. Thank you, panelists. One final question around the table. I've been choosing all the topics, but we've been at SC10 all week. Everyone wants to know what you think. Let's put this in the context of giving us one winner or one highlight from the show from your perspective, as well as one loser or one disappointment. Let's start with you, Jay.
Well, certainly GPUs were the winner in this show, whether you believe in their future or not. There was a lot of hype around it. There was a lot of results shown around it. The NVIDIA booth and other booths showcased some really impressive results. So I would say the big winner this year would have been GPU.
And disappointment?
Well, I don't know that I would say that it was a disappointment, but there certainly was general concern expressed about Lustre. I think that I actually saw lots of things that made me feel a little bit better about the near-term future, but I don't know if that was convincing to the community as a whole. I'm not sure that people really took the time to delve into what the new initiatives are doing, and they are relatively new. So you have to talk to them directly and find out who their developers are. Do they have a critical mass of developers? Do they have a plan for addressing some of the situation that's been created by the Oracle acquisition? So I think there's a perception maybe that Lustre is still on shaky ground, and it certainly is still on some shaky ground, but I think it looks a lot more promising than it did 3 months ago.
Thomas?
The highlights, it was a well-run conference. My congratulations to all the organizers and the committee. There were a lot of very good student activities. They're going out of their way to draw young people in. The field desperately needs it, and I think it was successful. Lowlights, well, first of all, I went to the Wolfe bash, and nobody knew me. And the other disappointment was that there was really nothing innovative that I saw, no imagination, nothing really compelling and interesting for me, but that reflects the field in its current position at the moment rather than any failure of the conference itself.
Lack of innovation at supercomputing may be a concern. Michael?
I think the details about the IBM Blue Waters and Fujitsu K system were a highlight for me. And the disappointment was the term legacy Fortran being used as a derogatory term. when your language or your platform is still in use 30 years from now, then you'll have the proud distinction of saying you've developed legacy software.
Peter.
Okay, a lot of it's been said. GPUs clearly mainstream. I think NVIDIA is clearly the winner in that space for now. That will change.
I'm sorry, that will change? You're predicting that's going to flip?
I'm not predicting it's going to flip. I think that NVIDIA is just so dominant right now, other players will come in. I wouldn't knock out Intel, I wouldn't knock out AMD. There's other things that are going to happen.
Okay.
HP, I mean, they've got themselves back in the top end of the top 500. Asia Pacific region as a whole, definitely. Losers, I'm just going to continue. I would like to thank Larry Ellison for making the vendor selection process much simpler than it ever used to be.
Well, thank you, panelists, for joining me on Analyst Crossfire. I personally had a great time moderating this panel and hearing the expert views from across the industry. I always enjoy the Supercomputing Conference, and I'll look forward to getting your views again next year. Thanks very much for Analyst Crossfire. I'm Addison Snell. Thanks for joining us.